Hello friends, today we will discuss about the inventory control in this inventory control chapter. We will discuss about the second module, and that module is simultaneous production consumption model. So we will discuss about the simultaneous production consumption model in the inventory control. So in this model, what we are doing is we are producing, not only producing, we are also consuming with the same time. So we are producing as well as we are consuming. We are selling, or you can say we are supplying the demand by producing on our own self. So we will discuss this particular model. So in this model we have some variables. Let us see, we have A as annual demand. So we have annual demand as A, and S is setup cost. So we have annual demand. There is a requirement of annually requirement of quantity is A. Setup cost is, for producing one item we have setup cost, and that cost is S. And we have another cost actual cost of the product, and that is cost per unit time, and that cost, or you can say per cost per unit, is C. And we have inventory carrying cost, and that is I. So we have here we have production rate, consumption rate, and production time. Three terms we have. One is production rate, another is consumption rate, and we have production time. So let us see these variables with a simple plot. So we have a plot with in between time and quantity. So same like earlier one, we have plot with time and quantity. So what will happen if you are producing with some rate? So we are producing with some rate, and that rate is P. With P we are producing. So if we produce with P, so we have some quantity, let us say Q. But what we are doing, we are not only producing, we are also consuming some item. So because of that, there is a decrease in the quantity. So that quantity will be I max. Why? Because we are not only producing, we are also consuming. Here we have model having both the things, production as well as consumption. So we have production rate. So we are producing the quantity, number of quantities per unit time by P, and we are consuming the same item by R. So we have production rate P and consumption rate R. So maximum inventory that can be stored with this production rate and consumption rate is I max. So we have production time. One time we have, that time is production time, but we have another time also, consumption time, but consumption time will be from this point to till the consumption of this particular quantity. So this whole time is nothing but consumption time. So we are consuming till this period. So when this I max will be consumed, what we will do, we will again start production. So we will again start production, and we have also we have regular consumption. So we have P minus R, again P minus R as a inventory. So we have inventory with the rate of P minus R, and maximum inventory we have stored is I max. So again we have production time. So for this time we are producing the quantity, and we are repeating the same thing. So again this cycle will be repeated, and again it will go periodically. So this is simple schematic, simple diagram in simple plot between quantity and time. So maximum inventory we are getting is I max. That is the maximum inventory, and this is because of the production, and we have some also consumption rate. So production rate minus consumption rate will store the inventory, and that inventory, that maximum inventory we are going to have is I max. So next we will discuss, again we have discussed these things. So next we will discuss some formula related to simultaneous production model. So we have first formula about simultaneous production model, and that first formula is EPQ. So in EPQ what we are doing? So in EPQ we have first formula, and that formula is EPQ. So we will see what is EPQ. So very first formula we have EPQ, that is economic production quantity. So economic production quantity we have. So what we will say, economic production quantity we have EPQ, and we have a formula for EPQ is this formula. So let us see what is EPQ. So economic production quantity, that is the quantity we are going to produce that will give maximum profit. So what should be the quantity, so that we can, if we are producing that quantity, we have a maximum maximum profit. So for for finding that particular quantity, that is EPQ, and we are denoting this by P star, we can calculate by this particular formula, where A is annual demand, S is setup cost, and CI is inventory carrying cost, P we have production rate, and R we have consumption rate. So we can find economic production quantity by making use of this particular formula. So we can EPQ, we have economic production quantity, and we can also known it as economic bag quantity, or we can say economic lot size. So this is the economic lot size. If we are going to produce this particular size, then we will have a maximum profit with the same setup. So we can find EPQ by another way also. So EPQ, economic production quantity. So some quantity we have. So let us say if this value is EPQ. So EPQ, how we can find? If it is EPQ, so EPQ we can find, we have a production rate. So production rate, how we will find production rate? Quantity produced per unit time. So quantity produced, that is EPQ per unit time. So that is TP. So we can find EPQ by cross multiplication of this. So we can find EPQ by P into TP. So one way for finding the EPQ by this formula, and this formula we are getting by differentiating the total variable cost in this particular model with quantity and equating it to 0. So we will find this particular formula for economic production quantity. Another way for finding the economic production quantity, by making use of production rate into production time. This will give you the economic production quantity. So we can find TP also from this particular formula if one is not given. If EPQ is known, P is known, then we can also find TPQ, and that will be equals to EPQ by P. So we have here maximum inventory formula also. So how much maximum inventory we are going to store, and that maximum inventory we have is P minus R. This is the P minus R into TP. P minus R into like this way, P minus R into TP will give you I max. Like we are getting EPQ by the formula P into TP. In the same way, we can find EPQ by the formula P into TP. In the same way, we can find I max by P minus R into TP. So I max is nothing but the maximum inventory we are going to store. So the maximum inventory we have in our hand, that maximum inventory we can find by the formula P minus R into TP. We can also find the formula for number of production runs. So how many times we are going to produce, and that means, say we have produced already here 2 times. So what will be this number 2, 3, 4, 5, so that we can have complete supply of annual demand A. So we can find this particular setup by A by this formula A by EPQ. Like earlier model, we have found the number of orders, and that is A by EOQ. In the same way, we can find number of production runs, because we are producing on our own. So we have to run the setup, and how many times we have to run, that number of times we can find by A by EPQ. So this formula will give the number of production runs we have to make, so that we can have a complete supply of this particular demand, and that demand is A. So we can find some other parameters also in the same way, like in the earlier model we have found. So we can find the total annual cost. So total annual cost we can find by fixed cost plus total variable cost. So we have fixed total variable cost, and total variable cost at economic production quantity we can find by this particular relation, this particular expression formula. So economic production quantity we can find annual demand, setup cost, inventory carrying cost, production rate, consumption rate, like that. So we can find total variable cost by making use of this particular formula. In terms of this particular formula, we can find also the total annual cost. So total annual cost will be at EPQ will be A into C plus total variable cost, and total variable cost is nothing but 2 into AS CI into P minus R by P. So by this formula we can find the total annual cost, and by this formula we can find the total variable cost. So we can find total annual cost, total variable cost by making use of these formulae. So next we will talk about the total annual cost at sum in general quantity Q. So we can find total annual cost at sum in general quantity Q, and that will be equals to fixed cost. Fixed cost annual demand into unit cost plus we have setup cost, or you can say in the earlier model we have ordering cost. Like that we have setup cost, and this is we have inventory carrying cost. Because maximum inventory is I max, minimum inventory we have is 0, so we can find the average inventory by I max plus 0 by 2, and this will give you the inventory carrying cost. So we can find total annual cost, total variable cost in the both the model. This will also give you the total variable cost, and this is total annual cost. So we can find total annual cost, total variable cost by making use of this particular formula. So we have discussed few formula related to the production consumption model. Next we will talk about one question, and that question is, this is the question, and we have to find, so we have to find number of production runs. So how many times we are going to produce, what will be the number of times we are going to produce, and also the total incremental cost in factory for the following data. So we have to find, so total incremental cost. So we can find total variable cost, that will be the total incremental cost in a factory for the following data. So we have to find total incremental cost, means total variable cost we have to find, and number of production runs we have to find. So total incremental cost, that is total variable cost, we can find at Q also, and that is A by Q into S plus I max by 2 into Ci. So by this formula we can find, or if you have to find total also the total incremental cost, so we can find by making use of this particular formula. So total incremental cost we can find, so we will see how we can find, and we can find the number of production runs, and that is A by APQ. So number of production runs we can find by making use of this particular formula, and total incremental cost, that is total variable cost or some general quantity Q, we can find by this particular formula. Or we can say if Q is not given, so we can find total incremental cost at EPQ. Total incremental cost at EPQ we can find by making use of this particular formula, and that formula is 2S Ci into P minus R by P. So we can find total incremental cost by making use of this particular formula. So that is total incremental cost or total variable cost at EPQ will be equals to 2AS Ci under root into P minus R by P. So by making use of this particular formula, we can find total incremental cost at economic production quantity. So let me discuss the things we have given. So we have some parameters given, and that those parameters are, we have annual demand of 15,000 units. So we have annual demand of 15,000 units, and we have production cost, that is setup cost per product, per order, or per production. So we have our per production run, this is 25 rupees 25. Inventory holding cost or carrying cost, that is Ci, and we have rupees 5. So we have Ci, so sometimes it is given I, sometimes it is given Ci both. So how we will judge what is given, and that can be judged by the time unit that is given. So if only I will be given, then there is no any terms of rupees or cost or dollar. So if Ci is given, then there will be a unit also of rupees. So we have inventory carrying cost, and that is rupees 5 per unit. So if you are storing one quantity, you have to pay inventory carrying cost of rupees 5, and that is for 1 year. Production rate we have 100, and number of working days in 1 year is 250 days. So we will find the consumption rate, and consumption rate is how much we are consuming 15,000. So we are consuming 15,000 in how much days? In 250 days. So this will be the consumption rate. So we can find consumption rate by this formula. So we can find consumption rate, and we have production rate is 100, so it is given over there. So consumption rate will be, we have consumption rate, and that is A by 250, and that we can find consumption rate by 60 units per day. So this will be the consumption rate. Now we will find the EPQ. So R is 60 units per day. So we have consumption rate 60 units per day, and we have also production rate 100 units per day. So we are storing 40 units per day. So this is nothing but in inventory. We are storing 40 units per day. So next we will talk here we have production rate is more than consumption rate. So we can use production consumption model for this particular problem. So we can find production in the with the help of production consumption model, the EPQ. So what will be the economic production quantity? So economic production quantity will be 2S by CI into P by P minus R. We have given A as 15,000, S 25, CI is rupees 5 per year, production rate 100 and consumption rate is 60. So we will put these values and we are getting that economic production quantity is 612.4. So it can be 612.4, or you can say it can be 613. So its economic production quantity is 612.4. So this is the quantity it will give you the maximum profit. So if you are producing with this number of quantity, you will have a maximum profit you have. Next we can find, so we have EPQ at 60. We have solved EPQ, and that is 612. Next we will find the Imax. So what is the Imax? So Imax we can find by P minus R by TP, and Imax we can find by the formula Imax equals to P minus R. This is production minus consumption rate, and into rate, this is rate. If you multiply the rate with the production time, you will get the quantity, and that quantity will be the maximum inventory we are going to store, and that storing quantity we can find. So we have to find first TP, and TP we can find by TP we can find the formula TP equals to production rate EPQ, economic production quantity, by production rate. So with this formula we can find TP, and TP we have, so we have TP, value of TP, and how we can find the value of TP. So we can find the value of TP as TP we can find. So TP we have TP you can find by this formula EPQ by P, and EPQ we have 612 and we have production rate 100. So TP will be EPQ by P, and that will be 612 by 100, and that is 6.124 days. So production time is 6.124 days. We will go for fraction only. We will not go for integer. So we will leave it as a fraction. So production time is 6.124 days. Production rate is 100. Economic production quantity is 612.4. So now we have maximum inventory, and that maximum inventory will be production rate minus consumption rate into production time. Production rate is 100, and that is 60. So 40 into 6. So 40 into 6. So this will give you around 245. So maximum inventory we are going to store, and that storing inventory is nothing but 600. That is the 245. So this is for one production run. So this is for production days, number of production days 6.124 days. So this is the production days. So per production run we are storing maximum inventory, at that maximum inventory is 245. We can find the number of production runs by making use of this particular formula, and number of production run is A by EPQ. A is annual demand, and that is 15,000 quantity, and economic production quantity is 612.4. So 612.4 for 15,000. So number of production runs will be how much? 24.5. So around 24.5 times you have to run this production, so that we can have a production quantity of 15,000, and you can find this particular value. So number of production runs we have. Now we will find total variable cost at EPQ, and we have formula that is the square root of 2AS CI into P minus R by P. So we have seen this formula. So we will find this particular formula. We have discussed this formula over here. So with this formula we can find, we have formula for this, and we have this formula is EPQ for formula P minus R by P. So 2AS CI into P minus R by P. So we can find total incremental cost or total variable cost. So by this making use of this particular formula, so we have total incremental cost, or you can say total variable cost. So that will be 2s into ci p minus r by p. So here 2a is how much? A we can have 15,000, s is 25, ci is 5, and production rate is 100, consumption rate 60, and it's 100. So by solving this for this relation, we can have a total variable cost, and that is called total incremental cost at this particular quantity. In general quantity, we can also find for in general quantity, but that quantity is not mentioned over here. So we will find total incremental cost at economic production quantity, and this will give you the answer. So with this, we have completed a few things about production and consumption model. So next we will talk about the inventory control, and in this case we will discuss another model, and that model is inventory model with shortage. So we will discuss about inventory model with shortage.